Hi everyone, welcome back to EE Education, where we simplify electrical engineering concepts for you. Today we are going to explore some fundamental network theorems, Thevenin's theorem, Norton's theorem, Superposition theorem, and the Maximum Power Transfer theorem. These theorems are crucial for analyzing and simplifying complex circuits. Let's dive right in. So first we see the introduction to network theorems. Network theorems are powerful tools that help us analyze and simplify electrical circuits. They provide methods to reduce complex circuits into simple forms, making it easier to solve for currents and voltages. We will start with Thevenin's theorem. Thevenin's theorem states that any linear electrical network with voltage and current sources and resistances can be replaced by an equivalent circuit consisting of a single voltage source VTH in series with a resistance RTH. So here's how you apply Thevenin's theorem. Identify the portion of the circuit you want to analyze. Remove the load resistor if present. Find the open circuit voltage VOC across the open terminals. This is your VTH. Find the equivalent resistance RTH seen from the open terminals. Turn off all independent sources. Replace voltage source with short circuit and current source with open circuit. Let's take an example with a circuit having a 10-volt voltage source in series with a 2 ohm resistor and a 4 ohm resistor. We want to find the Thevenin's equivalent across 4 ohm resistance. So we will find VOC, VTH, the voltage across 4 ohm resistance when the 10 volt source is active. Using voltage division, VTH is equals to 10 volt into 4 ohm upon 2 ohm plus 4 ohm, which is equals to 10 volt into 4 ohm upon 6 ohm, which is equals to 6.67 volt. RTH, the resistance seen by the 4 ohm resistor when the 10 volt source is replaced by a short circuit. In this case, RTH equals to 2 ohm. So the Thevenin's equivalent circuit is a 6.67 volt source in series with 2 ohm resistor. Norton's theorem. Norton's theorem is similar to Thevenin's theorem. It states that in any electrical network can be replaced by an equivalent circuit consisting of a single current source IN in parallel with a resistance RN. So here's how you apply Norton's theorem. Identify the portion of the circuit you want to analyze. Remove the load resistor if present. Find the short circuit current ISC across the open terminals. This is your IN. Find the equivalent resistance RN seen from the open terminals. This is same as RTH from the Thevenin's theorem. So for example, using the same circuit, we find the Norton's equivalent across 4 ohm resistor. First we will find IN, the short circuit current when 4 ohm resistor is replaced by a wire. So using current division, IN is equals to 10 volt upon 2 ohm, which is equals to 5 ampere. And RN, this is same as the RTH, which we already found to be 2 ohm. So the Norton's equivalent circuit is a 5 ampere current source in parallel with a 2 ohm resistor. Next is superposition theorem. It states that in a linear circuit with multiple independent sources, the response, voltage or current in any element is sum of the responses caused by each independent source acting alone, with all other independent sources turned off. Voltage sources are replaced by short circuits and current sources by open circuits. So here's how you apply superposition theorem. Select one independent source, turn off all other independent sources, means replace voltage source with short circuit, current sources with open circuit. Solve the circuit with the active source, repeat for each independent source, sum the individual responses to get the total response. Consider a circuit with a 10 volt voltage source and a 5 ampere current source. Voltage source alone means replace the current source with an open circuit and solve the voltage across a resistor. Current source alone means replace the voltage source with a short circuit and solve the voltage across the same resistor. So total response will be the sum of individual voltages from step 1 and 2. Next is maximum power transfer theorem. The maximum power transfer theorem states that the maximum power is delivered to the load when the load resistance RL is equal to the Thevenin's resistance RTh of the network supplying the power. So here's how you apply maximum power transfer theorem. Find the Thevenin's equivalent circuit. Set the load resistance RL equal to the Thevenin's resistance RTh. Calculate the maximum power delivered to the load using the formula P max, which is equals to VTh square upon 4 into RTh. For example, using our earlier Thevenin's example with VTh equals to 6.67 volt and RTh equals to 2 ohm, the total resistance RL should be also be 2 ohm for maximum power transfer. So P max will be equals to 6.67 volt square upon 4 into 2 ohm, which is equals to 44.49 upon 8, which is equals to 5.56 watt. So to summarize, we covered Thevenin's theorem, replace a circuit with a single voltage source and series resistance. In Norton's theorem, replace a circuit with single current source and a parallel resistance. For superposition theorem, analyzes circuit with multiple sources by considering each source independently. Maximum power transfer theorem determines the load resistance that maximizes the power transfer from the circuit. Understanding and applying these theorems will make analyzing and solving complex circuits much simpler. Thanks for watching. I hope this video made network theorems clear and easy to understand. Don't forget to like, share and subscribe for more videos on electrical engineering topics. If you have any questions, drop them in the comments below. See you in the next video. Happy learning!